all the metals make what kind of charge?
+2.
They all make positive charge, so make +2, +1, can go quite high, but +1 and +2 are very common charges. And so they're not the same anymore. We saw the same with the non-metals. Chlorine as a gas is extremely toxic, right? But that's neutral chlorine. If you have chloride, which is a chlorine ion, you eat that all the time. Chloride is in table salt. So it's very different properties when it's an ion versus the neutral compound. So he just had seen pure scandium metal before. He had seen it in an ionic compound as a charged species, as an ion, but not as a neutral compound. All right, let's get out your lab sheets from yesterday. So in the very beginning, we did Introduction to Matter. That was one of our first units, and we talked about the way matter could change. It could change chemically, and it could change physically. So can anyone remember any of the ways that we can see evidence that a chemical reaction can occur? There were several that we talked about, but it's been a few months since we talked about them. Anything that's evidence of chemical reaction versus physical?
Releasing, absorbing heat.
Heat changes is one. And yes, use the vocabulary words of endo versus exothermic. Anything else?
Gas release.
Right.
Color change.
Color change. And these are just evidence of, if I see a color change, it doesn't have to be a chemical change. It's just an indicator that maybe a chemical change has occurred. If you turn on your stove, if you have a classic electric stove, what happens to the coil?
Red, orange.
Right, it turns a red-orange color. That's not a chemical change, it just got hot, and now it's emitting that energy in a form that we can see. But that's a color change, that's not necessarily a chemical change. Bubbles, I can see bubbles when I boil water. Is that a chemical change? It's still water after, so that seeing bubbles or seeing a gas doesn't have to be a chemical change, it's just an indicator that it might be. And anyone remember any other ones? All right, let's look at what you actually saw in your baggie, so in the initial reaction. And so the very first one you did, when you put all the ingredients together on the other side of the paper. Sit, what's something that happened?
It built up gas.
Okay, you have gas production. How do you know it made gas?
Because the bag started to fill up and you had to let the air out.
Okay. Any other evidence that gas was formed? Anyone catch?
It smelled like extra marker.
Okay. Having a fake vapor, you smell vapors, you smell things in the gas form. No one else caught it? For some of you, you said it, maybe you're just not thinking about it, you said that you heard, you could hear it fizzing, you could hear the bubbles when it was in there. Zen, what's something else that happened?
The calcium chloride started to change color and it got it turned to like a pink, red, orange-ish color.
Yeah, so we had a color change, so what was the color of the things before?
White.
Alright, so we had white, and what color was the indicator?
Like a dark green.
Okay, so we had white and green in the beginning, and then at the end, it kind of made what?
Like it's a mix of like purple, orange, blue, from all of them.
Yeah, you saw a variety of colors as it was happening, but when it was all done, when you mixed all together at the very end, what color was it? It was an orangey pink color. So if you saw a rainbow of colors, it's just because you didn't completely mix up the bag. If you had mixed it all the way, it would have kind of gotten an orange color, and it would have still seen some of the white in there, which is what you're saying with pink. What else, Alexis?
It was isothermic.
Okay. What does that mean?
It became
Right, so you felt the heat released or felt warm to the touch. Anything else, Paul?
I didn't catch anything else, or I didn't write down anything other than those three.
Okay. What about Sam's group? You guys added extra indicator. Did you see anything different when you added some extra?
The white spherical like pellets, they started to dissolve and like get a lot smaller, whereas before they would just stay the same and the white fine powder would mix with the indicator.
Okay, so as you added more liquid, you said more dissolved. And why'd you pick the word dissolve? Because some other people said melt. That looked like it was melting. So why'd you pick dissolving?
Well, because it was just mixing with the indicator, it wasn't really like boiling away or like changing the state at all.
Okay, so melting, what you're saying implies that it was being heated. So since you weren't heated, maybe it was doing something else.
Yeah, because it was already done with all the heat and stuff.
And they noted that it was getting smaller. Some people thought it was getting smaller because it was melting. Some people thought it was getting smaller because it was dissolving. But in both cases, it seemed to be going away or to be disappearing in some form. Dissolving is the right word, dissolving because there was water in the indicator, so it was dissolving away. What about this color? Was it translucent, transparent, opaque? We used those words before, yeah.
It was more of an opaque and it kind of had like a frothy texture to it.
So if it's opaque, what does that suggest about how much dissolved?
Enough dissolved to change the color, but it didn't dissolve enough to make it clear. It's like salt water. When you have salt dissolved in water, it's clear, but it did not dissolve enough for it to become clear.
Okay, so the frothy goes with the bubbles. And when you're using those terms, clear versus opaque, do you remember what kind of mixtures those are?
Opaque is heterogeneous.
Right, so we made a heterogeneous mixture, whereas salt water would be.
A homogeneous mixture.
Right, so when we talked about the mixtures a long time ago, our true solutions are homogeneous mixtures, light can pass through them. Those are the ones that are transparent. It could be clear red or clear blue, but the light can still pass through it. This one was opaque. You could still see the chunks in there, which means you could still see the parts, so it was a heterogeneous mixture. Instead, some of it did dissolve, but it didn't completely dissolve, so you could still see the distinct parts to it. Right, so which of these things are evidences of chemical change, Carter? The ones that main big picture things you need to focus on. Color change is one. Change in heat.
Gas production.
Okay. And why didn't you pick dissolving?
Oh, I didn't pick,
Dissolving is what kind of change?
it's still change.
It's a physical change. If I put salt in water, I still have salt in water. They're just mixed together. So this is just forming a mixture. So forming a mixture is a physical change. It's not a chemical change. So if you pick that, it did change, right? It's just it's not the kind of change that we're looking for. We're looking for a chemical, not a physical change. All right, so we want to figure out what caused the gas production, what caused the color change, and what caused the heat change that we saw. All right, so flip over to the other side. All right, first thing that you mix together, Sarah, indicator and water. What happened?
It stayed green and it didn't have temperature change, it produced gas. Not a lot happened, it was mixed together.
Okay, so do we have any indication that there was any chemical change? No, we just formed a mixture. And what kind of mixture was it?
Homogeneous mixture,
And why do you say homogeneous?
because it was completely mixed together. There was no definite distinction between the two things that we did that.
Right, and what about how much light could pass through it.
And you could see light on the other side.
Right, so that was a transparent, this is our vocab word, transparent solution. Okay, so this one is a pretty dark one. I didn't dilute it very much, but that is green, and you can see through it. All right. What about the next one? Aaron, indicator and sodium bicarbonate.
It changed colors.
Okay, what kind, tell me the color change.
Like it changed to like I think that was one that was like the grayish bluey color.
Okay, so what was it before?
It was the white, and then the indicator was like the dark green
Okay, so the green became
and blue.
more blue. Okay, so more blue. Was it transparent or opaque?
It was very opaque.
And what does that mean if it was opaque?
It's the hetero.
Right, you can still see the powder in it. Okay, anything else? Did you get any bubbles, heat change?
No, it stayed like room temperature-ish. And there's no grass.
Okay. Zach, do you have anything to add to those first two?
There was no gas produced.
In which one?
Oh, so I agree with the top one. I don't have anything else to add,
Okay,
other than the no gas for both of them. And, we thought for B, that it was endothermic, cause ours got a little bit cooler.
alright, so it felt cool to the touch. Anything else?
I do not believe so.
Okay, tell me about C, indicator and calcium chloride.
It was very exothermic, so it got pretty hot.
Okay,
There was no gas produced.
okay,
There was a color change, it turned like purple.
okay,
However, the solid did not, like, it didn't dissolve, so it remained, like, separated from the indicator.
okay, and what's that vocabulary word?
Hetero,
Right,
heterogeneous.
hetero, you can see distinct parts, so you can see the little balls of calcium chloride separate. Did they get smaller?
I don't remember.
Okay. Anything else?
No.
Okay. Sam? Do you have anything to add to C?
No.
Okay, what about D?
The,
The water and the sodium bicarbonate.
there was, we said there was no reaction, the substances mixed, and it's created a white opaque liquid.
Okay, so what kind of mixture is that?
Homogeneous, no, heterogeneous.
Okay,
There was no gas created, and, it was cool to the touch, so maybe endothermic.